for the Polygon DevX tool, and this is something that uh, I how do I play this?
The slideshow option on the right side.
Okay. Is this one slide? Oh, slideshow. Yeah. Awesome. Sorry for that. So yeah, this is the topic for the discussion that we have today. And here, basically, the crux is that I want you to focus on development if you are building out a protocol, because that is what you are supposed to be doing. And I just want to fortify your security muscles while you develop. That is it. I do not want you to go all out, learn formal verification, and you know start certain approvals or something, become extremely ingrained in security. I just want you to have a very good understanding of security while you do development. So, about me, I already told you that I have been doing a bit of security stuff in crypto for a while. You can have a look at the website that I have, successism.com. I just posted it in the chats. So yeah, the Pareto principle. Of course, even the most seasoned auditors and security professionals do not have the answer to how do I secure my protocol 100%. But that does not mean that we do not think about our protocol security, because we have to think about the security so that don't get hacked. And what if I told you that you could dedicate 20% of your efforts, of your mind space, of your you know planning and rigor, and get 80% of the benefits of full security counseling? So that is basically the Pareto principle, where you essentially put 20% of the efforts to get 80% of the results. So in this talk, let's focus on what that 20% of the efforts look like. Uh, since we are focusing on development, let's get something out of the way right now. Of course, for the overall prime security of your protocol, I believe that there is a holy trinity of DeFi user safety. The first is you have to test your protocol quite a bit. Second is you have to get your protocol audited, and then later on a bug bounty platform, ideally. And the third thing is that you have to get your protocol insurance, or at least encourage your users to get user insurance. This insurance part is basically the last ditch effort that you can have to bring in some kind of safety net. But this is something that should be part of every protocol. But this is something that is not the focus of the topic today. The focus is security while development. So I think I do not need to talk much here. That is security even important for smart contracts or not? Because I think it already is. Already everyone knows that it is very important. There are two primary reasons for that. The biggest reason is that Web3 dApps deal directly with money. If you consider Bitcoin and Ethereum and Shiba Inu or Solana, whatever, as money, as value exchanged goods, then it becomes very important that they are bug free, because any breach would directly lead to the a loss of funds, which you do not want. And the second thing is the nature of blockchains. Anything ideally deployed once on blockchains cannot be changed, cannot be altered. So any bug introduced in a contract when deployed cannot be changed. So the natural counter to the second point would be proxies, right? You can always upgrade your contracts using proxies. Um, that is true, but I am not a big fan of proxies, and perhaps I'll tell you the reason down the line why. But you should always treat your smart contract development as if you are doing some kind of rocket science, because once a rocket is launched in the space, you cannot do anything about it. Similarly, once a smart contract is deployed on the blockchain, you cannot do anything about it. I know about proxies, but just think in that sense right now. Uh, so the one of the reasons why I don't like proxies is this particular tweet. So for projects that are not very well known, and the reason that many of the anonymous projects are accepted in crypto because of the nature of crypto itself, this kind of attacks are very common, where contracts are upgraded to basically include functions that can rug pull the entire TVL of the contracts, which is something nobody likes apart from the hacker. So yeah, we need to be careful of this stuff, and this is basically why I always try to go for non-upgradable contract. Right. Any questions so far? Anyone would like to speak anything? Just type in the chats or raise your hand. I'll see it. Right. Pulkit, you can let me know if anyone wants to say anything. Uh, Great. So very recently, I was auditing a protocol called Impermax Finance. I mean, it was not Impermax Finance, but it was what should I say? Fork of Tero Finance, which was a fork of Impermax Finance. So it's basically a fork, and it essentially encapsulates the principles of Uniswap V2. And the guy that is behind that protocol, Simon Rigolan. Let me show you. Sorry. Yeah, this is the guy. And he's basically the founder and developer of Impermax Finance. And he says that he has a set of principles that guide his DeFi development methodology. And one of the biggest points that he emphasizes on is that the smart contracts which secure the user assets should be as simple as possible, non-upgradable, and permissionless biased. So the non-upgradable thing is a big part of his philosophy. And you would have also known about the recent Euler hack that happened, where the donation function was used to basically create a very unhealthy position and then create a lot of stuff and steal a lot of money. So that was again introduced as an upgrade of an existing contract, and that was done post audit. So yeah, let's just go on with the assumptions that proxies should not be a default choice, and we should really, really have a deep discussion on whether we actually want to have it or not in the first place. Okay, so if you think about security, is it any different thinking about it as an auditor, as an external auditor, or thinking about it as a protocol developer? Is it any different? So, anyone wants to take a stab at this? Anyone wants to say anything about this? Like, it's this question, like, uh, the way that auditors see security and developers see security, is there any difference?
I think I guess the main thing is the bias. So when you're writing up smart contracts, you obviously like the mindset that you are writing that particular smart contract, you go through a particular flow,
Yeah.
but you often miss some things which an auditor might not because he's not biased towards a particular protocol.
Mm-hmm. Okay. I got your point. And Doctor Who says that there should be no difference. Okay, let's tackle this question from what I think of it. So, even if you want it or don't want it, for the better or the worse, the protocol developers themselves have a huge familiarity with the protocol code base, and it has upsides to it. Basically, where they can implement features and implement changes in the contracts on a moment's notice because they understand everything. But the downside of that is that they have a lot of biasness towards their logic. I mean, if you are the one who has created the entire logic for the protocol, you did not obviously want to create a buggy contract, right? According to you, your contract was solid, foolproof, and as secure as possible. So you obviously wouldn't see a lot of issues with the contract. I mean, it's like you have taken the happy path in the protocol where everything that you expected would happen, if it happens, then the protocol is safe, right? So I have met a few teams where they have said that we have done an internal audit of the protocol, which is, I mean, what this least strongest word I can choose for them is like team of bullshitters, because internal audit doesn't mean shit unless and until you have a really large organization and there are really competent developers in other teams who haven't seen your code. Um, Apart from that, if developers from the same team are reviewing it outside of peer reviews and calling it an audit, it's really bad. Okay, and the second thing is that the time and scope requirements. So when an auditor gets access to your repository, this is where the kicker comes in. The auditor usually takes like a week, 2 weeks, 3 weeks maximum to go through your code base and figure out all the stuff that is wrong with it. And as developers, we usually have this, conflict of in our minds thinking that, hey, it took us like 6 months or a year to develop this protocol. How can they know within 2 weeks that it is it right or is it not right? Is it wrong? Not wrong? How can they tell us something is good or bad? Well, the answer to that is the third point. It's the breadth of knowledge. Sure, you would have definitely a higher depth of knowledge in your protocol, but as auditors, I can assure you that we see like a lot of protocols following the same kind of patterns and anti patterns and trying to do the same things with different changes. So overall, if you look at enough protocols, you'd start seeing patterns where things go wrong, and it comes to a point where you don't actually have to understand the logic of the code in the first iteration. You simply can pick out all the implementational issues just as you see the code itself. So you have to trust the auditors in this sense that they will find issues. So this point basically was to highlight the importance of audits post your development. I mean, even if you listen to this entire presentation and you develop your protocol
Actually select an auditor. So
Mhm.
there are a lot of auditors out there, right?
Yeah,
And like obviously the famous organizations who do the auditing, they take a lot of time. There's a quite a
yeah.
queue for getting your contracts audited from those protocols, right? Or from those
Mhm.
particular organizations. So
Yeah.
how do you select a particular auditor in a pool of individual auditors?
Right. So it basically depends on your goals, what your goals are. Let's first of all think, why did audits become a thing in the first place, right? So audits became a thing in the first place because people started writing smart contracts way back in 2018, 19, 20, whatever. And obviously, since there was no common body of knowledge on how to write it, there were a lot of bugs here and there, and people lost a lot of money. So users kind of demanded that there should be some kind of audit or a security review from an external examiner who would do this, and basically that badge of getting audited from an external examiner would give the users the confidence to invest in the protocol. So that was the entire reasoning behind going for audits, right? So if as a protocol you I mean, like this is a very valid use case, but if you're trying to raise funds quickly, or if you are, trying to open your beta or something, if you're trying to quickly open your V1, you have to go for the quickest option, and the quickest option is the whoever you can find. As simple as that. You reach out to different people on Twitter who have, some experience as independent auditors. Either they have showcased their or should I say, skills in public contest, in bug bounties, or have a vast body of work, of previous work, you reach out to them and you get it audited. Use that badge to get on quickly. Uh, However, if you want to go for a very comprehensive security audit, then you have to involve both these independent security auditors and then the big audit houses such as Trail of Bits or Stamp or whatever.
Yeah.
And even in independent security auditors, you can see what all protocols they have audited in the past. And suppose if you are a lending protocol, and if you see that this particular independent auditor has audited like 6 different lending protocols in the past, then that is perhaps a better match for you rather than a star auditor who has never audited a lending protocol. So, yeah, that is something that you can keep in mind.
Awesome.
Okay. Right. So I have been a developer, and I still do some development for like protocol. So, and of course, I'm an active auditor as well. So I do know both sides of the equation. So here, I would like to share some personal experiences. Um, as a smart contract developer earlier, I used to think of smart contract security as a big amorphous giant, something that definitely existed but never made complete sense to me because it was presented as something really complex, and if you mess up somewhere, then all the money gets lost. So if that is you, if that defines you, if you are scared of security, I just want this presentation to be something that can get you out of that mindset so that you can focus on what you do best, that is development, and do a fair bit of secure development in that space. Right. So this slide is essentially the meat of the entire presentation. This is the 20% of efforts that I was talking about, and this is what will get you 80% of the secure results. This is a guarantee from my end that if you can work out these 3 different issues in your protocol, if you can absolutely be sure that you have checked, rechecked, and then checked some more about these 3 issues, then the auditors will have a very, very hard time finding something bad in your protocol, right? And here's another point. As an auditor, if I receive a protocol that is, very, very hastily made, it's been done in like 2 or 3 months, and the auditors were, the developers were from Fiverr or Upwork who didn't want to do it or were doing part time and didn't pay much attention to the contracts, then there are a lot of surface level security issues. And the problem with that is, if as an auditor I find, say, 20 critical issues in a single iteration, I am not going to look more into the protocol and find more issues. I'm simply going to call it a day, send the audit report to the protocol, and get it over with, right? But the fact that I found 20 critical issues in my first iteration does not mean that there were not any more deeper bugs in the protocol. There could have been, and there must most probably be more bugs. So if you provide your auditor with a code base that is very, very well tested, that is very, very well securely written, then you are the one who provides the auditor the permission to dive very deep into the logic and semantics of your protocol to find the very unique, the very 0-day kind of bugs that black hatters go for. So, it's kind of like uh, dream. Teamwork makes the dream work. Things like that. So think of the auditors as your team, as being in the same team, and then your dream of being hack free would come true, right? So yeah, back to the point on pillars of smart contract security for developers. So the first thing is that you have to have state control over your access control and input validation. So for the first point, I'd say that smart contracts are static by nature. As I told you, smart contracts are just a thing that lies on the blockchain. That is it. The logic cannot be changed. The values cannot be changed. Values can change, of course. The logic cannot be changed, right? So the only realistic attack vector that there exists are the functions that take user inputs, right? If you think about it, how can someone exploit a smart contract if it is static by nature? If the only attack vector that exists is or are the functions that take user inputs, right? Um, Along with that, of course, we also mean external calls made to other contracts. That's kind of in the finer prints. But yeah, so if we clearly guard who can pass values to our functions and then validate what was passed, we become much more safe than you'd think. This includes all the calls made and values received to and from another smart contracts, including tokens, including some sort of oracles, including some sort of other DeFi protocols. So if you get the gist of this point, you'd realize that this is the root cause of at least 75% of the hacks that happen out in the world, at least. If blockchain contracts are static by nature and the only way that you could hack them was through your own involvement, and that involvement was via external slash public functions and external contract calls, then if you just focused all your entire attention on validating the input that is received from functions and who is giving that input and validating them, you would be safe beyond like like your wildest imaginations. Like just this simple single thing, right? This would help you a lot. Uh, to this effect, there was this hack that happened very recently, uh, 10th of August. Let me post it here. The pigeonhole effect. I don't know what is that. Doctor, who can you like? Would you like to speak on that? What is that? Anyway, I mean, if you want, you can just. Right. Anyway, if you want, just ping here. I'll invite you to speak. Cool. Uh, so if you look at the hack and what has happened here, I hope you can see my screen and it is big enough for you to read what is there. So the first step is the user calls the regenerate many functions to make themselves an arbitrary number of tokens. The bug lies in the fact that you don't actually need to own any tokens to regenerate tokens. So this was again an external function, a public function, which could be called by anyone. So first of all, there was no input, no access control, anyone could call it. And then even with the input that was received, there was no validation of the input. So they violated our very first commandment of secure DeFi development, and they got hacked. No wonders. Learn. Uh, so I hope you understand the importance of this very point and how this itself is responsible for like a huge part of your security. And if anyone wants to say anything or Pulkit, if you have any thoughts, just feel free to stop me. And if not, let's go to the second point. The second point is keeping it simple, stupid, which is not a Web3 principle, not a blockchain principle. It is a software engineering principle which has been in use for even before I was born. Like it is it dates so far back and it has been effective since then. So if you had seen Sam Cousin's talk in the DeFi Security Summit last year, he had a very, very, very interesting point that you should keep your functions very short. Each function should do one single task, and that is it, nothing else. So this sounds very trivial, I mean, of course, one function would do something and won't do lots of different things. But when you start doing development and you say function deposit, right? Then that deposit function would check who the owner is. It would check if they have the balance or not. Then they would basically transfer to some escrow amount, and that would call some other DeFi protocol contract, and that would do some kind of conversion and things like that. And that is all happening in a single function. That is something that you want to completely avoid. I mean, you should be willing to look stupid just to have very clear code. You don't need to look very smart because the need, I mean, your desire to safeguard your users' fund should be greater than your desire to show off your programming genius. That is basically the last point. Do not let your ego come into the picture where you basically have to show off some fancy gas saving trick or have to show off some crazy front running attack removal mechanism that you came up on your own. Do not do that. Uh, and the hard part about this is we have to use established open source solutions and not build everything from scratch. Not because it it alleviates us from our you know security commitments, but simply because that code has been more battle tested and has been proven to work under a lot of different circumstances, especially if it is something, Solidity point 0.5 version or something, then we know for a fact that it has stood the test of time and we can use it. Because you would never know what kind of change that you introduced in that contract leads to what kind of butterfly effect down the road and you get hacked. So this point was very beautifully illustrated in Simon's, what should I say, thread. Here you can have a look at it. Yeah. So he's talking about the Euler hack. I hope you can see my screen. And in the Euler hack, it says that first of all, let's look at the first fundamental. The protocol should be as simple as possible. Why Euler implemented in the protocol core such a high-level function as donate to reserve? Apparently, it wasn't even useful. So the hack happened due to a function called donate to reserves, and as it turns out, it wasn't even necessary, right? So the fact that you should keep your protocol as simple as possible and as, what should I say, dumb as possible, it cannot be overstated. You really have to keep it as bare bones as possible. And if you're looking for inspiration on how to do that, just go through the Uniswap V2 code and understand how the core and periphery functions contracts work, and try to wrap your mind around it and kind of implement those in your development journey. Uh, any thoughts about it? Just let me know, Pulkit.
Also, like the second point that you mentioned, that don't go for fancy gas saving tricks, but
Yeah.
we know that gas is very essential when we are developing smart contracts, and obviously when
Yeah.
people are transacting through those smart contracts, we need to minimize the gas. So as in, how from a develop smart contracts developers perspective, how do we manage this expectation? Obviously, for my own protocol and for my own
Yes.
set of smart contracts, I
Yeah.
want a particular method or a function to consume the least amount of gas, right?
Mm-hmm.
So I see there's a trade-off, as you mentioned, that I
Yeah.
shouldn't go for very fancy tricks, but as in, then how should I manage that particular aspect?
Right. So, first of all, the problem that you mentioned is not a problem. It is a dichotomy that needs to be managed. You will always have to decide on a meter. Uh, like you have to, shift the meter at some place, and the left end extreme of that meter is extremely robust code, and the right end of that meter is extremely gas efficient code. both cannot be achieved at the same time, but you have to determine on what you want. And that is very context driven, to be very honest. For example, if you are developing, say, a lending protocol, right? And as a lender, you'll have to interact with your protocol once while giving some lending, and maybe once a month when you want to collect your interest rates or something, right? And if that is the kind of interaction you have, and you have a decently sized portfolio, like something like $1,000, $1,000 or above that, then you do not really need to risk the robustness of your protocol for like a little saving, like 500 gas or something like that. You should not do that. But if you are a protocol like DYDX, something that has to have a lot of transactions and very quickly, and again and again it has to happen. That is where you cannot afford to have a lot of gas. You cannot afford to be slow, because the protocol logic itself require everything to be very fast, and that is the reason perhaps that they shifted from traditional blockchains first to L2s, then to Starknet, and then to Cosmos, who created their own chain. So basically, you have to understand what your protocol is trying to do, and try to find a good balance between how you want to keep your contracts. For example, what I mean by extremely, what should I say, extremely fancy gas saving tricks are is something like the Solidity. I think everyone would have heard about Solidity. Solidity is basically a set of contracts that you can use to, like EIP712.sol. This is an alternate to Open Zeppelin, but this is extremely, extremely gas efficient, because this essentially does not use Solidity at all. All this uses is Yule and assembly. So this is very efficient, but I would say this is fine, because their entire aim is to be an efficient library, not be a protocol which has user funds, right? So what their goal is to become an alternative to Open Zeppelin for high performant protocols. So this is something where you are, like, you have the freedom to go for very extreme gas saving tricks and tips. And the slight issue that people do not think about with these kind of things is that even for the auditors, it becomes quite difficult to audit things like that, because you have to take into consideration the skill level of the auditor itself themselves. And if you provide them very complex code in assembly, not only will they take a lot of time, they may come across something that is new to them and maybe miss a few things. So yeah, just uh, just understand what you want to do and go according to that.
Right. And from a auditor's perspective,
Yeah,
do the auditors themselves, suggest some things as in alternatives to how you have written your particular, let's say,
yeah.
a particular function or a methodology that you, or or any sort of function or any sort of piece of snippet of code on in Solidity
Hmm.
that you have written, do they recommend other approaches as well, or it's just that the auditor's role is to just see what vulnerabilities a smart contract has and
Yeah,
just check on that?
right. So this is the audit that I did for Brahma Finance, their newest offering, which is the Brahma console. So as you can see, I have the high findings here, medium findings, low findings, informational findings, and then I have an entire section on recommendations, right? So the recommendations has a lot of things that I thought could be better improved, that they could, try to implement, which are not a security issue, but they can drastically improve the user experience, or things that can become security issues down the line, right? So, for example, let's think of usage of ABI.encode instead of ABI encode packed in requires strings in executor.sol. Executor.sol will result in easier decoding. This is not a security issue, but this is a recommendation of what I think would be uh, necessary.
Right.
So yeah, this I mean these are the kind of things that you can expect from an auditor, and even there are things like gas findings. So very trivial things like setting of local variables to zero is not needed. Struct packing and what should I say? Do while loops can not initializing variables inside do while loops, things like that you can definitely do away with and save some gas, but you do not need to jump into assembly if you are not very comfortable with that to save a few gas here and there. So yeah, the level of gas saving that you do should basically not exceed your skill levels, and you have to be very true to yourself to understand what your skill levels are. So any more discussion points here, or should we move on to the next?
I think
Yeah.
we can move on to the next slide.
Okay. And if anything, guys, if you're still there, you can add it to the chat. Right. So the third thing is formal language and theory of computation. So here we are getting to the hard-hitting point of security as a developer. You would say that formal language and theory of computation is something that the auditor should look into, and the white hat should look into. Why, as a developer, I should look into it. The reason for that is that you have the most context of the protocol. You are the one who is present at the time when ideas are being discussed, ideas are being put into English language, and then English language is being converted into diagrams, and diagrams are being converted into code, right? So you are the best person positioned to use formal language and theory of computation to make your protocol as robust and as hack-free as possible. So what do I mean by formal language and theory of computation? So in a very crude sense, if you could break down each component of the protocol into a state machine, and that is essentially what formal language is. If you can break down your protocol into components, and each component has some sort of state machines, and state machines take some sort of input, does some processing, gives out some output, and basically you can represent your entire protocol as some interactions of state machines. You would have formally verified your protocol, because in that way you could visually see that what could go wrong with your protocol and what cannot, because everything is there out in front of you. And if you can do that, uh, well, it's like an extreme level of security. So yeah, when we do this, the protocol should look like a mesh of different state machines interacting with each other to carry out the protocol logic. Which I said that state machines would interact with each other. They take in arrows and inputs, give out arrows as outputs, and if any arrows land at an undesirable state, there you have it. There is an issue. There is a bug. You can fix it right at the issue, right at the root of it. So how does it look if you do it? So this is the machine that describes the functioning of a calculator. So this looks very difficult and strange, but trust me, if you study or theory of automata, formal language for even 2 days, 3 days, a week or so, you'll be very easily able to understand what is going on here. You'll be very easily to break down, like seriously, like large protocols into these kind of diagrams. And you see these particular arrows, right? So if these arrows they are made according to the laws of formal language, and they do not match with your expectations of the protocol, then that means you have found yourself a spicy bug right at the get-go. So yeah, this is slightly more advanced, slightly more difficult, but you know what? You do this and you are head and shoulders above your competitors in terms of security. That's my guarantee. The natural extension of this formal the natural extension of this thing that we talked about is formal verification. I think you must have heard of it, the Certora provers and whatnot. All this is being done quite a lot, and this is gaining quite a lot of adoption as we speak. I think this is something that we talked about here. Uh, see, so Hats Finance, in collaboration with VMix, I think, did audit competition where they, you know, uh, they had the contest to write proper formal verification test, and where at the end they added bugs to verify how many will be found. So these kinds of things are picking up, and you could basically see things in action for yourself if you try to understand what is happening here. And you could also get a lot of help from all the people that are doing it, because frankly speaking, these guys, I mean, I've interacted with them a bit, and they are hungry to help you. I mean, they are just on the lookout, on the prowl that who wants their help. So yeah, you can talk to them. They are like really cool people. So do we have more time, Pulkit, or is it done? I think it's
We'll defer the question to
yeah.
G Rabix in this case.
Mm-hmm.
I believe we are already up time, but if
Okay.
there are any pressing topics that you still like to continue, I think the folks are staying in. So anything that you need to
No, well, just let me very quickly see. Just give me 1 more minute, okay?
Sure.
The thing is, once you're done with this and you still feel a bit of uneasy with your protocol security, what should you do? Do a shitload of testing, test the shit out of your protocol, write unit test, integration tests, cross integration test, uh, any kind of test that you can think of, and write some more. Yeah, and personal experience part two is that as an auditor, when I receive code base and I see the test cases that are written for the protocol, I usually find that the areas that have not been tested very well are the areas that you find a lot of bugs in, because the only reason that the developers did not test their protocol's specific part could be that they either did not understand it very well themselves, or for some reason they were scared to test it. In either of those cases, it is very likely that you will find bugs. And if you reverse engineer from that end as a developer, then test the shit out of your protocol. Do not leave any part of your protocol untested or undertested. Okay, and testing the shit out of your protocol means also write lots of first tests, both stateless and stateful. Stateful first tests are essentially invariant testing, so that is out of the way. Yeah, so now with that, you have something solid. Can you go even beyond? Yes. If you are really, really, really into security, you can start going with test driven development, where basically you write tests for a very small piece of code, you commit that, and you again write a very small piece of code and test that and go ahead with that. It's basically a circle where your test should fail. I mean, the design of your protocol should be outlined by your test. The test should fail initially, and you should write your protocol in such a way that the tests start passing. That's it. You can read up more on test-driven development, and if there are ways to implement that in your things, you can find that. Um, who should test my protocol? Anyone that you can find, uh, bring them into tested. Thanks for sticking around. Thank you. That's it.
Just a question. So I think we have quite a devs here. I don't know what type of audience we have, but like if you could share a list of specific tools, frameworks that you recommend for identifying, these security vulnerabilities and all
Mm-hmm.
that you use quite often, or you recommend devs to use, that'll be great.
Oh, okay. So since I am an auditor myself, I usually use my pen and paper. That's it. But I have a few tools that you can use. Let me find the link for that. Uh, it. Hmm. I mean, first of all, you can definitely use that thing from Trails of Bitworks. That software. Oh. I mean, the only thing that you can use essentially from for your security is automated static analyzers, and I will share a link to the static analyzers that I think are good. Apart from that, there isn't really anything that you can use to find uh, things. In yeah.